Okay, folks, as promised, just going to talk through in a bit more detail some of the object-oriented concepts that we discussed in lesson today so that you can apply them in your own work. It's also important to remember that this is not easy. It's a completely different way of programming to what you've done before. And for some of you, it's a quantum leap in what you've done before because you're only just getting your head around using sub-programs. But it's still a vital part of the spec. And if you get your head around it earlier, it helps you with several different areas of what you need to do. So what I've done here is I've broken down the program into 3 images. So what we've got at the bottom here, this is the actual where the program runs by creating an instance of our game. So remember that an instance is an object. So an object is where we take a class and we make a version of it actually running. So I could have more than one game running, but in this concept it wouldn't make sense. We're going to have a look at that in a second. And then we run here the method run game. So we've got 2 classes. We've got class player. These are the blueprints for what a player can do. So this is what a player can do. Now a player can set score. A player can give us a score by using the get score method, and the player can set their choice. So we've got here, just make myself some space by rubbing out some bits. Right, in this space here, we have our attributes. So these are like variables. They're the data of that object. So each class can have various attributes. For example, for your cells, you might have your height, your weight, your hair color. They are your attributes. Now, in our game class, so this is how we actually run our game. You'll notice that both this and the player class have this def underscore init. Now it's important in the way that Python shows this, it's not easy to see that it's actually done like so. So it's double underscore. Now this is your constructor. It creates the object, a version of this class. Now, very often people say, why do we need self? Well, self is a common thing that's in all elements of object-oriented programming, and it just tells the object to look at itself. So each object will have its own attributes, and it will keep track of its own attributes, so its own variables is one way of looking at it. Now in this one, let's just clear our screen. We have the method check victory. Now this is slightly poorly worded. So this is the game checking who has won a round. So this is the code for checking who has won rock, paper, scissors. It also has a method set rounds, which is how it can change the number of rounds. So remember what we talked about in Python, where everything is public in Python. You can access anything from anywhere. But this is me trying to show you a private method. Sorry, not a private method. This is a method that's accessing a private attribute. So this allows the user to change what's in rounds. Okay. And then what we need to look at there is how this figures this out. And then this uses basic logic. So if the player's choice, player 1 choice and player 2 choice, are the same, then it would print draw to the screen. If they're not, it then uses a series of elif statements to see who deserves a point. So self player 1 choice is rock and self player 2 choice is paper, well, we know that player 2 has won because paper beats rock. So we, player 2, set score. Now this is where some people were getting confused. How does it get to this? Well, down at the bottom here, I told you we created an instance of an object, that object being the game. Now in our game constructor, player 1 and player 2 of the game are both instances or objects. Now an object is an instance of a class. Okay, so self.p1 is a player with the name Bob. So let's just clear out this so we can have a look at this. It's an instance of the class player with the name Bob. So self.name becomes name. Score 0 choice is blank because they haven't made a choice yet. And then player 2 is exactly the same, except we don't call it Bob, we call them Dave. And we set the rounds of the game to 0, and we start, that's that class made. So we come down to our actual program, we then run the method RPS, so we've called our game RPS, short for rock, paper, scissors, .game. So RPS is a object, it's a game, and we've got the method run game. We have a Boolean variable, run equals true. We have a condition controlled loop or condition controlled iteration. What we then have in here is self.setRounds. So we're calling the games, so self, the object itself, so the game, it's setRounds method, which is here, which adds 1 to self.rounds, so we know that a round has happened. Then P1 choice, P2 choice, we created some variables where we are using the methods of the two players to get their choice. So for player 1 object, it would set its choice, and player 2 object, it would set its choice. So you can see here, what this is doing is what we've talked about with the flow of the program. So next, we've got those two choices. From the game, we do game.check victory. Okay, now in fact, that should be self.check victory, but it works. So self.check victory. We come up to here, it runs this part of the code to see who's won. And then we print the score for player 1. We print the score for player 2 because they are our objects up here, P1 and P2. And then end run, this is how we control closing it all down. We get input from the user and we concatenate some data together, including self.rounds, how many rounds there have been. We sanitize our input, spelling that American way, to lowercase. If the user puts a lowercase e, run becomes false, so our loop will end, otherwise it keeps going. And then we can see here, once we come out of the loop, we run self.winner, which is this method, which looks to see who has won. Now you've got access to all of this code in its entirety with the REPL link. Hopefully this will help you make a bit more sense of it. If not, send me some questions, work your way through this, try and program this yourself to make sure you understand it. I know I'm giving you the code, but that's part of the process of learning. Next week, I'm going to set you a task where I don't give you anything that you have to do. If you've got any questions, find me an email or a Satchel One question or a comment on Google Classroom. Cheers, folks.